Okay, so we're on k is equal to 3 now, right? And like I mentioned before, we're going to need the values from the previous table, which in this case is k is equal to 2, in order to do the next table, k is equal to 3, right? And just like before, we're going to take all values here, all vertices here that are not infinity, right? So we want 1, 2, 3, 4, and 5, right? So we're going to basically do the same thing again, except this time, instead of using just 1, 2, and 3, we're going to use 1, 2, 3, 4, and 5 because there are more values now which are not infinity, right? So let's start. So for 1, so I do not here this time, we have v1, v2, v3, v4, and v5, right? So if we so we now have to go back to the graph, and we have to see if v2 could reach v1, if v3 could reach v1, if v4 could reach v1, if v5 could reach v1, and so on. Take the smallest out of that again and update, right? So now we know from this table none of those values could reach v1, right? So for all of them we're going to put infinity, well, besides this one, because this one is nil, this one is 1 trying to reach 1, which is impossible, right? So there's some is infinity, right? And we just put v1 as it was in the previous table, 0 and nil. Cool. So now we're going to do it for 2, for value 2 now, column 2. Same story again, v1, v2, v3, v4, and v5, right? Now could we reach 2 from v1? So we go up here and we see yes, we could reach 2 from v1 at the cost of 2. So we update it here. Could we reach v2 from v2? No, we just put nil. Could we reach v3 from v2? Yes, we can reach v3 from v2. Could we reach 2 from v3? Could we reach v2 from v3? Right? No, we cannot reach v2 from v3, so we put infinity. Could we reach v2 from v4? No, we can't, so we put infinity. Could we reach v2 from v5? No, we can't, we put infinity. The reason we can't reach v2 from v5 or v3 to v2 or v4 to v2 is because the arrow is pointed away from v2. So that's the reason why we cannot reach it, right? So we're going to put infinity for v5, right? And the smallest here is 2, so 2, and the parent is 1, right? Now we're going to do this for 3, for the next column, which is 3. So 3, v1, v2, v3, v4, and v5, right? So we want to know if we could reach v3 from v1. We go up to the graph. We could reach v3 from v1 at the cost of 4, right? So we update that here. Want to know if we could reach v3 from v2. Could we reach v3 from v2? Yes, that will cost -3 plus the value from our previous table. Now remember we are on k is equal to 3, so the previous table we are going to use as k is equal to 2, not k is equal to 1 as we did before. So we're going to say we're trying to see if we could reach 3 from v2, right? So we could reach 3 from v2, yes we can, and the cost is -3 plus cost from the k is equal to 2 plus 2, which is -1 again, so we leave it -1, right? 3 to 3 we put back nil, right? Could we reach v3 from v4? No, we can't reach v3 from v4, so we put back infinity. Could we reach v3 from v5? No, we can't, so we put infinity, right? So the smallest value here now is -1, and the parent is v2, right? Now we do it for 4. Right? v1, v2, right? Could we reach 4 from V1? No, we can't reach 4 from V1, so we put infinity. Can we reach 4 from V2? Yes, we can reach 4 from V2 for the cost of 1 plus 2, which is 3, right? Could we reach 4 from V3? Yes, we could reach 4 from V3 for the cost of negative 4 plus negative 1, right? So negative 5, right? Could we reach 4 from V4? So we put that nil. Could we reach 4 from V5? So could we reach 4 from V5? Yes, we could reach 4 from V5 for the cost of 4 plus 2, 7, right? So the smallest value we take in here is negative 5, and the parent is 3, right? Now we're going to do 5. Alright, we'll do it on the side. So V1, V2, right? So could we reach 5 from V1? No, we can't, so by infinity. Could we reach 5 from V2? Yes, we could reach 5 from V2. The cost will be 5 here plus 2 here, 7, right? Could we reach 5 from V3? Yeah, we could reach 5 from V3. The cost is negative 2 plus negative 1, which is negative 3, right? Could we reach 5 from V4? No, we can't reach 5 from V4, so we put infinity. And 5 to 5, we put nil, right? Now we're going to choose the smallest, which is negative 3, and the parent is 3, right? Now we do 6, right? Could we reach, oh sorry, V1, V2, V3, V4, V5, right? Could we reach 6 from V1? No, infinity. Could we reach 6 from V2? Nope, infinity. We can't reach 6 from V3 either, and we could reach 6 from V4 at the cost of 8 plus 0, which is 8. And could we reach 6 from V5? Yes, we could. The cost is 6 plus 2, which is 8, right? So in this case, the smallest value we have is 8 and 8, right? So in a case like this, we could choose either one. In this case, I'm going to choose V4. So 8 and the parent is 4, right? So we just completed k is equal to 3. Now it's the same exact step for k is equal to 4 and k is equal to 5. Now I'm going to complete it outside of this video, but I'll make the final video showing the final steps in the Bellman for algorithm.